Hello again, all you fabulous Ford students. Mr. Pierce here, and I want to talk to you today about Earth's motions and seasons. Our learning goals today: by the end of this lesson, you should be able to model and illustrate how the Earth rotates on its axis. And you should also be able to model and illustrate how Earth's tilt and revolution around the sun causes the seasons. So let's start off with our first learning goal and look at about how Earth rotates on its axis. Now, Earth rotates or spins once every 24 hours, and this is what's going to cause day and night. Earth's day and night are caused by this rotation. The side of facing the sun experiences day, while the side facing away experiences night. It takes about roughly 24 hours for the Earth to make one complete rotation, or a whole day. So to kind of illustrate this, we have here, using kind of a golf ball to illustrate it, you can see the sun shining from the left side over here onto our golf ball, and you see that this golf ball is lit up on the side facing the sun, but on the back side facing away from the sun, it is in darkness. So if we were over here in the United States, over here on the other side of the world in China, they would be in darkness. So we're having day. On the other side of the world, they're having night. Now, Earth rotates once on its axis every 24 hours, but it is going to revolve around the sun, and this is going to take 365.25 days for it to revolve completely around the sun. Now, as it revolves around the sun, it's not a perfect circle. It actually revolves in an elliptical or oval path around the sun. So you can kind of see our diagram here. We have it kind of egg-shaped. You can see right over here, we are a little further away from the sun, and right here, we are closer to the sun. It's often a misconception. People often think that, hey, we're closer to the sun here, so that's when we're having summer, and over here, that's when we're having winter. That is totally false, and we're going to show you what actually causes the seasons today. The reason for the season is Earth's axis. Earth's axis is slightly tilted at a 23.4 degree angle. The tilt of Earth on its axis causes the seasons. So this tilt on the axis is going to certain positions on its revolution. Certain hemispheres, north or south, are going to be pointing towards the sun. And so the hemisphere that is tilted towards the sun receives more direct sun and will experience warmer temperatures. So therefore, it's going to be summertime if they're tilted towards the sun. Now, the hemisphere that's tilted away from the sun receives less energy and has cooler temperatures. So if the northern hemisphere is tilted towards the sun, the southern hemisphere is tilted away, the northern hemisphere is going to be warmer, and the southern hemisphere is going to be cooler. To kind of illustrate this, I have a diagram here. So you can see in our position over here on the right-hand side, we have our northern hemisphere. Right up here, that's everything north of the equator. And it is tilted away from the sun. So what is actually happening is it is receiving less direct sunlight from the sun, and it's going to have cooler temperatures. Whereas the southern hemisphere right down here, or things south of the equator, it is tilted towards the sun. So it is going to be experiencing warmer weather, and it is going to be having summer. But as the Earth revolves around the sun, it gets over to the other side of the sun. Our axis is always pointed in the same direction. As we get over here to this side, now we see on the left side that the northern hemisphere is tilted towards the sun. It's going to have summer. The southern hemisphere is tilted away, and it's going to have winter. So in summer, when we're tilted towards the sun, you're going to be receiving, in summer, the sunlight is more direct and concentrated, providing more energy in a smaller area. So here's kind of just a little demonstration. Is we have a flashlight shining down on a piece of graph paper, and we see how the light is concentrated in a very small area. So we have the flashlight's giving off a certain amount of energy. That energy hits a very small area of the graph paper, and we have concentrated light. In winter, less direct sunlight, so here we have the flashlight tilted, spreads out, spreading the energy over a larger area. So this would be simulating what's happening in winter. We have it tilted, the light spreads out to a greater area, and so you have less energy per square. So let's look and analyze each of these seasons. In summer, what's actually happening are the days are longer and the nights are shorter. The longest day of summer is called the summer solstice. The summer solstice occurs on or about June 21st or 22nd for the northern hemisphere. And for the southern hemisphere, this is going to be December 21st or 22nd. Remember, we have opposite seasons in opposite hemispheres. So each hemisphere during summer receives more sunlight and therefore more heat energy during summer. And this is why temperatures are warmer during the summer. So let's look at this diagram here. We can see the northern hemisphere is tilted towards the sun. Sunlight energy is going to come in and hit it more directly, causing warmer temperatures. We can also see the Earth's tilted on its axis, tilted towards. We can see our North Pole's right here. And we see that the North Pole, if this were to spin on its axis, the North Pole is always going to be in daylight. So actually during summer, the North Pole will go months of total brightness, of total daylight. And that's why it's going to be warmer. And we have more hours of daylight. The light is spread out more. So here's another way of looking at it. We have our sun back over here. Now I've tilted the axis, and we have the northern hemisphere tilted towards the sun, and we can see we're going to get more of our direct energy right here. The light's coming in, and it's going to hit more directly right up here, and it's going to be warmer. And we see, again, how our North Pole right here is actually all lit up. So it's going to be, as it spins, it's going to be in total sunlight for several months. After summer, less energy is received on the hemisphere from the sun as it's revolving around, and that hemisphere is going to begin to cool down. Autumn, or fall as we sometimes call it, occurs after summer, and the days begin to grow shorter while the nights grow longer. On the autumn equinox, the daylight and nighttime hours are equal. This occurs on or about September 21st or 22nd in the northern hemisphere, and of course it's opposite in the southern hemisphere, so this is going to be March 21st or 23rd in the southern hemisphere. So here we see what's happening is the Earth is moved, its axis is always pointed in the same direction, and each side of the Earth is receiving equal amounts of sunlight. And so we're going to be going from summer in the northern hemisphere into getting closer to winter. So our axis is starting to tilt more towards the sun, and so or tilt further away from the sun, so the temperatures are going to start getting cooler. And here we have modeled at the equinox. Now days are shorter and nights are longer during winter. The shortest day of winter is called the winter solstice. The winter solstice occurs on or about December 21st or 22nd for the northern hemisphere. And of course the southern hemisphere is going to be opposite, so that's going to be June 21st or 22nd for the southern hemisphere. And what's happening in winter? Each hemisphere receives less sunlight and therefore less heat energy during winter. This is why temperatures are colder during the winter. So here we have the northern hemisphere tilted away from the sun. It's receiving less direct sunlight. If we look up here, Earth's axis, this is where the North Pole is, and you see if it were to spin on its axis right here, that the North Pole would not receive any daylight hours. So it is dark all the time up here during the wintertime. Another way to kind of demonstrate it, we see our sun again over here. Now we have it tilted away, and what you see is that the more direct sunlight is going to be down here in the southern hemisphere, and we are up here in the northern hemisphere. We're receiving less direct sunlight, so it's going to be cooler, and you can even see that the North Pole there does not have any light shining on it. So after winter, more energy is received on the hemisphere from the sun, and that hemisphere begins to warm up. Spring occurs after winter, and the days begin to grow longer while the nights grow shorter. On the spring equinox, the daylight and nighttime hours are equal. This occurs on March 21st or 22nd, or thereabouts in the northern hemisphere, and in the southern hemisphere this is on or about the 21st or 22nd of September. So here we see we're again at equinox, and our axis is running parallel to the sun. Hope you learned a little bit today, and I will catch you next time. Thank you very much.